Now, next part of the equilibrium is your ionic equilibrium. Ionic equilibrium. Okay, ionic equilibrium. Now, in ionic equilibrium, first we'll learn about, as it is ionic, so ions are present. So electrolyte is required. So what is an electrolyte? What do you mean by an electrolyte? Alright, electrolyte is defined as a compound whose aqueous solution or in its fused state, that is in the molten state, we can say, conducts electricity. Alright, that is, due to the presence of ions in the aqueous solution or due to the presence of ions in the molten state, it conducts electricity, and that particular substance is called as an electrolyte. That is known as an electrolyte, we can say that. So in aqueous solution or in molten state, in fused state, it produces ions are produced, and these ions helps in the conduction of electricity, we can say that. Now next is based upon this electrolyte, we are having two types of electrolyte. One is your strong electrolyte, another is your weak electrolyte. Strong electrolyte means a strong electrolyte is defined as a substance which dissociates almost completely into its ions. That is called as a strong electrolyte, which dissociates almost completely into its ions. A particular substance which in the aqueous state or in the molten state dissociates almost completely. For example, like that is your NaCl solution, sodium chloride solution, potassium chloride solution, potassium nitrate solution, HCl solution, H2SO4 solution. So these are and many more, these are considered to be a strong electrolyte. If you pass electric current through it in the aqueous solution state or in the molten state, we can say that it will dissociate almost completely into its ions. Alright. Now, weak electrolyte are what? Weak electrolyte are those electrolyte which dissociates feebly into its ions, which dissociates to a small extent in a solution, we can say that, in aqueous solution or in the molten state, which dissociates very feebly. That is called as a weak electrolyte. That we call it as a weak electrolyte, we can say that. Clear? So, which conducts electricity to a very small extent. Very small extent it conducts electricity. For that reason, it dissociates very feebly, weakly. Got it? For example, suppose if you take 100 molecules of NH4OH, let us say, because NH4OH is a weak electrolyte. Acetic acid is a weak electrolyte. Carbonic acid is a weak electrolyte. Formic acid is a weak electrolyte. Aqueous solution of this, let me tell you, aqueous solution of formic acid, acetic acid. Acetic acid means vinegar. Then carbonic acid, then you are having that is nothing but ammonium hydroxide, then calcium hydroxide, then barium hydroxide, magnesium hydroxide. All these are considered to be as a weak electrolyte, so to say. Now, if you take 100 molecules of it, let us say you have taken 100 molecules of ammonium hydroxide, you will find that is hardly 10 to 15 molecules will dissociate, hardly, and remaining 85 to 90 molecules will remain undissociated. Will remain undissociated. Now, meaning of the word undissociated means I am meaning to say you this one, that you have taken 100 molecules of NH4OH, it dissociates to give you NH4 plus OH minus. So if you take 100 molecules, out of that hardly 10 to 15 molecules you will be getting it. Here, that is 10 to 15 ions of NH4 plus and OH minus you will be getting it. Remaining will be undissociated. That is called as a known as weak electrolyte. That is known as a weak electrolyte, so to say, we can say that. Now, how do we know the dissociation, the degree of dissociation? How do we calculate the degree of dissociation? We calculate by using this formula. Alpha is known as the degree of dissociation. Degree of dissociation is called as alpha. I said, 100 molecules, if you take 10 to 15 molecules will dissociate, will remaining will be undissociated. So how do we calculate the degree of dissociation? Alright, by alpha. Alpha is equal to number of moles dissociated by total number of moles into 100%, because basically we measure the degree of dissociation in terms of percentage. So whatever you get it, you just multiply into 100%. That will give you the degree of dissociation. So in case of strong electrolyte, the degree of dissociation is around 98 or 99%, we can say that, in case of strong electrolyte. But in case of weak electrolyte, the degree of dissociation is less than 5% or less than 10%, we can say that the degree of dissociation is, we can say that it's a weak electrolyte if you take it. Alright. So in this way, the difference between the dissociation ionization, I have seen many students They sometimes say dissociation, they sometimes say ionization. No, you cannot use dissociation, ionization according to your wish or whatever it comes to your mouth, you will be saying it. No. Dissociation is a term used for ionic compound, and ionization is a term used for covalent compound. Remember it. For example, HCl is a covalent compound. When HCl is dissolved in water, it ionizes. We say ionizes. Ions are not there. Listen carefully. Ions are not present in HCl because it's a covalent compound. It's a gas. When you pass HCl gas through water, it forms hydrochloric acid. Similarly, H2SO4, it is also a covalent compound. When you dissolve in water, it forms sulfuric acid, nitric acid. Alright, so all these are nothing but what you can say covalent compound. So certain covalent compounds are polar in nature, you know that, you have studied. And those covalent compounds which are polar in nature, they are soluble in water. And when they are soluble in water, they dissociate to a certain extent. Alright, some they dissociate almost completely, some they dissociate feebly, we can say that. The one which dissociates almost completely, they are called a strong electrolyte, and the one which dissociates feebly, they are known as weak electrolyte, we can say that. Clear? So, in case of HCl, when HCl is dissolved in water, we say HCl ionizes. Automatically, the term will come, ionization. If you keep in your mind, that is HCl is a covalent compound, H2SO4 is a covalent compound, HNO3 is a covalent compound. We can say that. Clear? So, now, for NaCl, we don't say ionizes. We use the word dissociation. Sodium chloride dissociates into its ions. Because in case of sodium chloride, already the ions are there. Because sodium chloride is made up of ions only. Na plus and Cl minus combines to form NaCl. So in case of sodium chloride, ions are there, but the ions are not free. The ions are held together by strong electrostatic forces of attraction. Alright? On passing electric current, the ions are set free. In aqueous solution state or in the molten state, ions are set free. And these free ions helps in the conduction of electricity. So again I repeat, for ionic compound, we use the word dissociation because in ionic compound already the ions are there. We need to dissociate, we need to separate. So hence we use the word dissociation. In covalent compound, the ions are not there. The ions are formed. So we use the word ionization. We can say that. I hope you got it. Now, next is coming to, that is what you can say, based upon this degree of dissociation, we will study a law which is called as Ostwald's dilution law. First we will derive the law, then after that I will tell you the statement of the law. What I said? Ostwald's dilution law. Ostwald's dilution law. Now let me tell you before starting this particular one, let me tell you. Now in this chapter we are going to study mainly about the weak electrolyte. In certain cases, you will be studying about the strong electrolyte. Mainly, you will be studying about the weak electrolyte in this particular chapter. Because when an weak electrolyte dissociates, you have an equilibrium between undissociated ions and molecules. Undissociated ions. Alright, you will be having an equilibrium between undissociated ions and ions, we can say that. Clear? Dissociated ions and undissociated ions. Or we can say molecules and the dissociated ions will be having. For example, this. Just now I wrote it, ammonium hydroxide. Once again I am writing it, NH4OH. It dissociates to form NH4 plus OH minus. So this is your ions. And this is your undissociated ions. We can say that. Or undissociated molecules. There exists an equilibrium between undissociated molecules and ions, which is known as a weak electrolyte. Got it? There exists an equilibrium. We can say that. Clear? So basically in this chapter we are going to study about the weak electrolyte. Basically we are going to study. In certain cases you will study about the strong electrolyte also. So now the law which I am going to say you, the Ostwald dilution law, rather which I am going to derive now, the Ostwald dilution law, you will see it is true for weak electrolyte. It is not true for strong electrolyte. It is true only for weak electrolyte. It is not true for strong electrolyte. At the end of the derivation I will tell you why it is not true for strong electrolyte. Alright, you need to understand this. That Ostwald dilution law which I am going to derive it, which I am going to say you, it is true only for weak electrolyte, not for strong electrolyte, so to say. Okay, fine. So I will derive the law. I will take an example, like let me take an example of acetic acid, CH3COOH, alright, which will dissociate to give you CH3COO minus and H plus in aqueous state, definitely. In aqueous state, it will give you CH3CO minus plus H plus. Now, let me tell you, in general, for any acid, we use HA. This is in general an acid. It dissociates to give you H plus plus A minus. Ha stands for any acid. Generally it's a weak acid, I take it. Because as I said you, in this chapter, in this particular Ostwald dilution now, we are going to deal with a weak electrolyte because it is true for the weak electrolyte. So generally I'll take this particular acid as a weak acid, so that there will be an equilibrium between undissociated molecules and ions. We can say that. Clear? Similarly, for the base, what we write in general, BOH. For the base, any base. For any acid we write it as HA. For any base we write it as BOH. So BOH dissociate will give you B plus and OH minus. Because for acid H is compulsory, it has to be there, and for base OH minus is compulsory, so OH minus has to be there. So in general, for any base we write this, and for any acid we write this. Alright, you need to understand this, because this I'll be using it later in this particular chapter. I'll be using this particular one, HA, BOH. So from the beginning itself I'm saying you what is HA stands for. HA stands for any acid and BOH stands for any base, so to say. Fine. Now in terms of that only I have taken, that is one HA example I am giving you in front of you. You can see that in the front of the screen, you can see on the board I have written you. I have written it here. That is HA here is CH3COH, and H plus we got it here, and A minus is CH3CO minus. I hope you understood. So in this way, what we find is that it dissociates very feebly. I have said you already, because it's a weak electrolyte, it's a weak acid. It dissociates very feebly. Fine. So initial concentration. This is your C, this is 0 and this is 0. The concentration is. When we start the reaction, then only acid is present. This is not there. When we start the reaction. Initially means when we have started the reaction. Now, next is concentration at equilibrium. Concentration. Now, before calculating the concentration, we need to understand, we need to discuss that whether it dissociates or not. Yes, it dissociates to CH3CO minus and H plus. I think you are following. CH3CO minus and H plus. The degree of dissociation is alpha. Let us say alpha. So how much will be remaining here? 1 minus alpha. Isn't it? Initially 100%. 1 means what? 100%. So here alpha dissociates. So how much is remaining? 1 minus alpha. Got it? Clear? Yes. Now next is I have written concentration at equilibrium. So I will multiply C throughout. Alright, so a concentration at equilibrium is C into 1 minus alpha. This is C alpha and this is C alpha. Again I repeat. Initially concentration is C. Let us say it is 1 molar or 2 molar or 3 molar. So it is C is here 3 molar or 1 molar or 2 molar or 5 molar, whatever it is. So when I have started the reaction, this is there. This is not there, of course, when I have started the reaction. Product is not there, no? Reactant is only there, no? Isn't it? After that the product, it comes. Alright, when we start the reaction, when the reaction proceeds and the product comes. But when you have started, this only reactant is there. Then after that it dissociates, and hence it dissociates to how much? Let us say alpha moles dissociates at equilibrium. Alpha. This is the equilibrium sign, you can see. At equilibrium, alpha moles of H plus, alpha moles of CH3CO minus, you are getting it. So how much remains here? 1 minus alpha. 1 means what? I said you, degree of dissociation measured in terms of percentage. So 1 means how much? 100%, we can say that. Clear? But we are not writing in percentage here. So we are writing only the number. So hence it is alpha. So as a result, this is also a number. 1 minus alpha. Fine. So now concentration I have set. So I will multiply C throughout. That's it. That I can do. No problem. Now, we will see equilibrium constant. Already we have seen the equilibrium constant. We have studied in chemical equilibrium. So here it is an acid. So I will write it as Ka. If you would have been a base, I would have written here Kb. If I would have taken a base, then I would have written here Kb. But as it is an acid, it is Ka. Understood? It's an acid here. So acetic acid, so I have written Ka. Suppose here I would have taken ammonium hydroxide. I would have written Kb, because ammonium hydroxide is a base. So understand it. Ka stands for acid dissociation constant. This is known as acid dissociation constant. If I would have taken here ammonium hydroxide, then I would have written here Kb. Kb stands for base dissociation constant, so to say. Fine. So Ka is how much? Concentration of the product by concentration of the reactant, that is CH3COO minus into H plus by CH3COOH, concentration of the product by concentration of the reactant, so to say. Now, what is the concentration? Now, here the concentration which I am putting in, I will be putting the concentration at equilibrium, because Ka is what? That is acid dissociation constant. When it is calculated? At equilibrium. We have calculated it. Okay, fine. So it will be C alpha, you can see it here. Then C alpha by C into 1 minus alpha. The C and C gets cancelled. It is C alpha square by 1 minus alpha. This is your Ka. We can say that. We got it. So again I repeat, if it would have been a base, then it would have been Kb. Just that much only. Kb C alpha square by 1 minus alpha. It is same thing this. No change. Got it? Because C and alpha, of course, it remains the same. We can say that. Clear? It depends on substance to substance. It will differ. Otherwise, it remains the same. Now, generally, alpha is very small. Is very small. 1 minus, so 1 minus alpha is equal to 1. We can take it as. Because alpha is very negligible. Generally, the value of alpha is 0.0000 something. So 1 minus 0.00 something means it will be 1 only. So Ka is equal to C alpha square. So in that case, alpha is equal to root over of Ka by C. We can say that. Got it? What I said? Generally, alpha is very small. Listen carefully. Alpha is very small. Its value is 0.0000 something in this way, 0015. Let us say. So 1 minus 0.00015 is nearly 1 only. If you subtract it, you will be getting to be as 1 only. How much it is? It's very small. The alpha values. Got it? So hence 1 minus alpha we take it as 1. Now generally, let me tell you, if the value of alpha is less than 5%, where you will neglect it, the value of alpha, and you will be taking to be as 1. Listen carefully. In the denominator only, because denominator is the substance solution it is. So don't what you can say neglect in the numerator. No, numerator is the ions. In denominator, this is 1 minus alpha. We got it from where? From the denominator. Mind it. So only you will be neglecting the alpha in the denominator, because what I said, that is alpha is very small. Got it? So hence 1 minus alpha is negligible in solution. Listen to my word very carefully. In solution. So where you are going to neglect, where we are going to take alpha is negligible. If the value of alpha is 5 or less than 5%, you may note it down this one. If the value of alpha is 5 or less than 5%, then alpha is negligible. Then alpha is negligible if the value of alpha is 5 or less than 5%. Means, suppose if it is given the value of alpha as 3.2 or 0.32. So 0.32 into 100 will give you how much it is? Nothing but it is 32 only. So there it will not be negligible. But if it is given that is nothing but 0.032. Alright, you have to calculate in terms of percentage. So into 100 you will do. So into 100 when you will do, you will be getting 3.2%. We can say that. So in that case it will be negligible. So hence I said you, if the value of alpha, listen carefully, if it is 5 or less than 5%, the value of alpha is 5 or less than 5%, then alpha is negligible in the denominator. So in that case 1 minus alpha is equal to 1. So C alpha square by 1 is C alpha square. So in that case C alpha square is equal to Ka. So alpha is equal to root over of Ka by C. I hope you understood. Now that is concentration is equal to what? Concentration is equal to 1 by V. Concentration is what is the formula? Number of moles by volume. So number of moles I have taken it as 1 here. You can see it is 1 I have taken initially 1. So hence 1 by V. So 1 by V means in place of C if I put 1 by V. Alright, it will be what? Root over of Ka into V. That's it. Alpha is equal to, so alpha is equal to either root over of Ka by C or root over of Ka into V. Understood? From where we got it? That is C is equal to 1 by V. C is what? Concentration. Concentration is number of moles by volume. I have taken here number of moles as 1 generally. Because generally when we start the reaction, we take it as 1. Like in maths, we have done, let it be 1, let it be 100. So here it is 1. We can say that in terms of number. So hence it is 1 by V. So hence when I put the value here, C is equal to 1 by V, I get it root over of Ka into V. We can say that. So hence we can do it in this particular way. If the value of alpha is greater than 5%, mind it, then the formula will be Ka is equal to C alpha square by 1 minus alpha only. If it is greater than 5%, I am saying greater than 5%, then it is not negligible. This alpha is not negligible. So hence Ka is equal to C alpha square by 1 minus alpha only. You can say that. Now how will you find alpha? You know it is a quadratic equation. You will use the formula root b minus b plus minus root over of b square minus 4ac by 2a. You will be using this and you will calculate. You will solve the quadratic equation. You read in maths this particular thing. Alright. Clear? Now, in this way, you can see that. Now, coming to the definition of the Ostwald dilution law. So, this is your formula. Alpha is equal to root over of K by C or root over of K into V. This is the formula, we can say that. Clear? So, coming to the definition, for a weak electrolyte, the degree of ionization, this is degree of ionization for a weak electrolyte, is inversely proportional to the square root of its molar concentration. See, it is inversely proportional to the square root of its molar concentration, or it is directly proportional to the square root of its volume. It is directly proportional to the square root of its volume or inversely proportional to the square root of its molar concentration. That is degree of ionization, we can say that. This is known as Ostwald dilution law. After deriving the law, I said I will give you the definition. This is your statement of the Ostwald dilution law. Again, I repeat, for a weak electrolyte, the degree of ionization is inversely proportional to the square root of its molar concentration, as you can see, or inversely proportional to the square root of its molar concentration, or directly proportional to the square root of its volume. This is your degree, degree of what you can say ionization, we can say that is alpha, which is written in the form of statement in Ostwald dilution law, so to say. Thank you.